I wanted to have a quick talk today just about my journey from kind of an OO developer to more of a functional developer. When I joined a company that Louis and Gary worked at previously, I gave a talk about solid principles in JavaScript and how we could apply OO design patterns in JavaScript, and we could still follow the great foundations. But today I'm going to take that further, because that was 2 years ago, and we will move forward and we will find new things, and we realise that we've made lots of mistakes in the past. But first of all, I just want to start all my presentations with this, which is something that Richard Solomon said, which is, give it 5 minutes. It's fine to have opinions. It's fine to, to give feedback and to debate, but just give it a chance first. Just listen and take it in. So my presentation is called "A Journey from Cats to Functions," or "How I Learned to Stop Worrying and Love Compose." Anyone who's watched any films might recognise that. So I think I'm right in saying that most people, when they start developing code or hacking away, don't start with object-oriented design. It's not natural. It's not something that you think, I'm going to write a program today. I'm going to write it with an object first. Most people start with some kind of procedural style, so they do scripting language like PHP or Python or JavaScript or BASIC, if you're like me. But then at some point, you realise that actually procedural code is very difficult to maintain and to read and to look around and to reuse bits. So someone introduces you to the idea of OOP, and OOP's main design goal was to solve reuse. And this is an article from Computer World in 1996, where they're debating whether or not OOP is right for enterprise. And the main point of this article is that OOP will mean that developers won't have to write code anymore, because they'll have pre-made things that they just reuse, just objects. They'll just compose them together and they'll be done. Obviously, we all know that that's a fallacy, as is the idea of reusing code, but we'll talk about that another day. So you get introduced to OOP, and I have been a loyal OOP practitioner. I was knees deep in OOP. I enjoyed it. For me, it was doing everything right, and the classic inheritance is cats and dogs and pets and animals, and it solves everything, doesn't it? Makes everything much better, and it's the thing that everyone does. The big names like Martin Fowler and Bob Martin, they all use OOP. They write about OOP. They make a lot of money on the talk circuit talking about OOP. OOP's the way forward, and you can build some really beautiful code bases with OOP, and I have as well. And you're proud of them, and when you're designing them, you have lots of big design sessions, and you talk about them. You talk about what patterns you're going to use, and you make these beautiful code bases, these crystalline palaces of code, and it's all great. And you've done the job, and it serves a purpose, and it does the job. But then, 3 months down the line, you have to change that code base, and you realise what you've actually got is a massive mess, because it's really hard to understand what you've done. It's really hard to reason about how you've written that code and how different pieces of the puzzle fit together, because you've abstracted a lot of it away in inheritance cycles. So OOP was good, and it's enjoyable to do, but it does have some downsides. And so then you come across, there's lots of quotes out there about why OOP's not great. Richard has got some good ones. Joe Armstrong has as well. But then you come across the idea that, and this is from a talk by Alan Kay, is it? Essentially talking about late binding. When you learn this, can you easily go back and change this? So that's the point. You've made this massive code base, and you learn something new. Oh God, how do we change that thing there? It's not easy. So I was meant to talk about solid. So solid is solid principles. People know what solid principles are? No? Well, I'm going to get onto them, talk through them in depth. But solid was meant to solve this problem. But solid was meant to say, how do we write OOP? How do we stick to the OOP paradigm, but write it so that it is easier to reason about and easier to extend and change and maintain? And my thought today, and what I want to share with you, is that I think that solid naturally leads you to functional programming. A lot of the ideas around solid principles lead to functional programming, and that's why I think our adoption of FP isn't some massive revolution. It's just a natural evolution. We are moving more towards solid, therefore we in the end up with functional programming. So solid is great, But there are byproducts to solid in OOP, and that is that you end up with very verbose code bases, because if you follow solid all the way through to fruition, you end up with tiny small classes that contain one method, and that class has to implement one tiny interface, and that interface might only have that one implementation. And one of the key kind of alerts or signs that what you're doing might be wrong is that you have to, anyone who's read clean code knows that naming meaningful names are hard. Naming things is difficult, but you make the problem 3 times harder, because you've now got to name the function do, and the class doer, and the interface IDoer, and you have to do that for everything you touch. And you also end up with these huge dependency trees that are difficult to manage, and if you want to refactor code, you want to add a new dependency, you've got these huge constructors with all your dependencies injected into it. You have to change those. Maybe you want to change the 5th one. Now you've got to change all the tests to touch that, and you have to change all the other classes that implement that. So there's problems with that. So let's talk through some of the solid principles and how they really relate to functional programming. So the first one, the SRP, single responsibility. I think that's obvious how that fits with functional programming. We write small, discrete functions that have only one concern, and they have only one reason to change. So you do that with functional programming anyway. Openclosed. Does anyone want to say what that means, openclosed?
Can do.
Yeah.
It means that something, the wording is awkward. It says that something should be open to extension but closed to modification.
Yeah. And most of the time I've tried to address openclosed is you use things like the strategy pattern, where you have a number of things that implement an interface, and you pass whatever you're doing to the list of items, for example, and say, can you handle this problem? If you can, do your thing. But we can do that because in functional programming, functions can be substituted as will, and we can extend them through higher order functions. Because functions are first class citizen in functional languages, we can, rather than passing behavior around as objects that implement an interface, you just pass the functions around that do the behavior. So you simplify that problem. List of substitution. I didn't mean to click through, I was going to ask someone to remind me what L was. But, so that list of substitution is all about subclasses being substituted for their base class. And all you're really saying is make sure that your class meets all the expectations of it. And in terms of functional programming, we have composition over inheritance, so we don't have that problem because we're not having these massive problems with inheritance that you get in OOP. We also have things that are, every function is a singularity. You really want to get to singularity functions, so you can swap them in and out and put them in any order and they'll still work. Interface segregation. So you're talking about no client should be forced to bend on methods it does not use. And again, that's, I think it was Martin Fowler that termed role-based interfaces rather than header interfaces. So make much smaller interfaces that deal with the role of that thing in the system rather than a massive interface where 5 or 6 of the items never get used. You get around that in functional with partial application. So you might have 3 or 4 arity functions and you partially apply them, and then you give the bit that's important to the next function partially applied. Really didn't make much sense then. But anyway, you don't need role-based interfaces because the role of a function is explicit. Finally, dependency inversion. And this is the one that has 2 parts. So it's high-level modules should not depend on low-level modules. Yeah. And abstractions should not depend on details. Details should depend upon abstractions. So that's all about the fact that really, when you're doing OOP, you've got a lot of side effects going on, and you don't really want to, you don't care who's making your HTTP request. You want to put an abstraction around that layer, but your library that does actually make that HTTP request has to implement that abstraction. We don't have that as much in OOP, in FP, because we move side effects to the edges of the system, and side effects are more of a consequence of an action rather than being explicitly invoked as they are in OO. So that's why I think FP is the logical next step in following solid principles. And that's my presentation.